Alright, so in this video we're going to take a look at how to do frequency response in LT Spice, or the .AC simulations, also known as AC analysis. And so let's just get right into it. We're going to go based on the example that I did in the slides previously with the RC circuit. So let's just go ahead and build that circuit, starting with the voltage source. There's a couple of things that we're going to need to do that are different, so just make sure you're with me. I'll put the capacitor here. We're going to go ahead and use the same values. Let's just make this a 1 kilo ohm resistor, and we'll make this a 1 microfarad capacitor, and then we'll just come over here to our source. Oh, sorry, let's connect this up first, and then I'll show you what we need to do with the source, because it's different than what we've done previously. Okay, so let's ground there and there, and we will call this VI, and we'll call this VO, and we'll be ready to go. So nothing new yet, but the new piece here is that when we run a .AC analysis, we need to come into our source. So I'm going to right click on this source. We need to go to advanced, and you see these small signal parameters, the AC amplitude and the AC phase. We need to give this AC an amplitude of 1. That's basically going to enable, and I'll also make this information visible on the schematic just so we can see it. That's going to basically enable the AC analysis for this circuit. It's going to enable us to do the frequency response. If I don't put that in, I'll get an error when I try to run the AC analysis, okay? So let's go ahead and run the AC analysis. Again, what I did previously was I obtained the magnitude and the phase plots using just hand calculations. I got the magnitude function and I got the phase function, and then I plotted some points. Now we're just going to use LT Spice to do that for us. So if I hit S to go do a, like normally this is where I would run a .op or a .tran, but I'm going to run a .ac. The type of sweep I'm going to run is a decade sweep. Windows users don't need to go through these steps of actually remembering the analysis command. You will have a much better interface. But for those of us who have Macs, we need to remember the analysis commands. So it's going to be .ac, a decade type sweep. Then the next data point is how many points do you want per decade. Usually 100 is fine. You can do more if you'd like. I'm going to say .ac dec 100, and then I give it my start frequency and my stop frequency. So basically on my x-axis of these plots, where do I want the frequency to start? Where do I want it to stop? So for this one, let's just look from 1 hertz out to 100 kilohertz. And we'll hit OK, and I'll just place that down. And now I'm ready to run my .AC simulation. So I hit run. And here's my plot. So you can see my x-axis there. I've got 1 hertz out to 100 kilohertz, just like I wanted. And I want to plot V out. Well, I wanted to plot V out over V in, but that's basically the same thing because we made V in an AC value of 1, so it's not going to change at all when I do this. So you see it's exactly the same. That's what the AC1 means. It's basically telling you the amplitude of my input. If my input is 1, then V out divided by V in is the same thing as V out. So it's just for convenience, but to be consistent, I'll put this in V out over V in. And you notice that this is in dBs for the unit on the x-axis, and this doesn't look exactly like what I plotted. So the reason is because this is the Bode plot. Remember I talked previously about Bode plots and how we're going to get there and how we can approximate by just a couple of straight lines, and you can see that here, but that's not what I want right now. I want to do the linear frequency response, which is what I did in the slides. So come over to the y-axis here and hit right click or double click on it. You see that it's in decibel scale right now and the representation is Bode. Instead, just hit linear here and hit OK. And this is the plot that I derived in the slides. Okay, so I'm going to actually add a second plane. And what you can do is you can plot the magnitude on one and the phase on the other. So let me just copy this signal up to the top. So I've got magnitude. I've got the magnitude and phase on both right now, but if I wanted to, I can come over here, right click, and hit don't plot the phase. So now I just have magnitude up top. And I can come down here and right click on the magnitude side and hit don't plot magnitude, and now I get the magnitude and the phase on two separate plots. And this is basically exactly what we came up with in the slides. Okay, so this is how you do frequency response in LT Spice. If you have any questions, please let me know. You can see that this is exactly what we came up with. I'm going from a value of 1 at lower frequencies dropping off down to a value of 0 at higher frequencies for the magnitude, and for the phase I start at 0 degrees here, right? And then I drop off and come down to a value of -90 at higher frequencies, okay? Have any questions, let me know. I'm going to go ahead and end this video, and we'll see you guys in the next one.